Okay, so we're going to buzz through our final little lesson on proportion here. This is, as we've been saying, most directly applicable for Math 052 and 038, where it is literally one of the sections in your books. And so for 052, this is section 3.4. For 038, this is covered in section B6 in your line B book. This is also, and it's also directly applicable for Math 026. As you can see there, units 2, 3, and 4 go through the material that we're going to be looking at here in this lesson today. For Math 053, it's, I think, still valuable because these types of questions will come up. Now, if you have done Math 052 previously, then this will be just review, and you may or may not feel, you may feel pretty solid on it already. But there's always a fair number of people who assess directly into Math 053, so they didn't actually cover this material. Maybe they already knew it and got it right on their assessment, but you can easily get through each page of those assessments without necessarily knowing everything in the course. So if you assess directly into 053 and haven't actually done Math 052, a lot of these Math 052 lessons are actually potentially quite valuable for you as well, because they pick up, they'll fill in those gaps, and percents and proportions for sure are going to continue to come up in various ways throughout all math courses, all accounting courses, all types of courses you're going to do in the future, stats, everything. Okay, so this final one here, we're just calling applications of percentages. There's really going to be very little new math. We are just going to apply all of the things we've already put together. How to turn percent equations into, percent setups into ratio equations, which we can then solve using our little cross product shortcut. So remember that when we see percents, we want to be thinking we're setting up our ratios in terms of part to whole. And one of those is always going to be the percent. So here I've got 3 setups like the ones we did in our last lesson, where we learned 3 types of percent equations that come up, and we're not going to solve them. Let's just remind ourselves how we were setting them up, and then we'll move into some word problems. So whenever you look at these, you want the left side of the equation to be the percent to 100. And so in all 3 of these, you see I've identified in red where the percentage appears. This one, there's a 78%. This one, there's a 23%. And this one, there's a what percent? An unknown percent. But they all have a percent. So the left side of the first equation is 78 to 100. There's your part to whole for your percent. The second one, 23 to 100, 23%. And the third one, unknown. So we're going to give that a letter. I'm just using n this time, n to 100. So you can see in all cases with percent equations, when you're setting up your ratios, the left side is your percentage to 100. Always. You can get that in there right away, real easy. And then the question you need to ask is what goes on the right side of those ratios. So you are basically looking for what is the part and what is the whole. So in this case, 78% of 260. That's the key there. And in fact, look at that. We put them all in blue. It's usually the word of. I could twist the words around so it's not the word of specifically, but usually it's easier to spot what is the whole as opposed to what is the part. So 78% of 260. 260 is the whole. And then in this one, 23% of what number? 55 is 23% of what total? N is the total unknown number, N. What percent of 840 is this other number here, 590, 840 is, I don't know what I just said. I meant to say 592. 840 is the total, the whole. And now we're looking for the part. So in the first example, the part is unknown. What is 78% out of 260? What unknown number? In the second one, 55 is the part. So 55 is 23%. So 55 is only a small part of the unknown number. 55 is the part, N is the whole. And what percent of 840 is 592. How much out of 840 total is 592? 592 is the part. We can get situations where the part is bigger than the whole, so don't just take the bigger number, smaller number, right? You have to read the language to make sure you set these up right. We're not going to solve these, but we could. You would turn each of those into a fraction equation like we did before, and once they are fraction equations, use that little cross product shortcut that we've been doing to solve them. Okay, so there's our reminder of how we set up percentage ratios. We're on the left side, we put the percent out of 100 ratio. On the right side, it's the part out of the whole ratio. All right, so let's look at some word problems here. All right, Jana ran for mayor in her town. 62% of voters voted for her. If there were 8,529 voters, how many people actually voted for Jana? So we know she got 62% of the vote. How many actual people out of the 8,529 was that? So let's look for our percentage first. 62%. Look through the question, spot that percentage, because that's the left side of your equation always. 62 is to 100. As on the right, we want to find the part and the whole. Well, there's 8,529 total voters in the town. That sounds like the whole to me, right? Now, out of those 8,529, how many voted for Jana? That is the part, and in this question, the part is unknown. So n to 8,529. Now, and I talked about last time, there are shortcuts to all of these percentage ones. And you can memorize, oh, in this case I do that, in this case I do that, in that case I do the other. The problem is if you walk away from it for a while, there's nothing wrong with that, by the way, but if you walk away from these types of questions for a while and then you run into one again, it's really easy to have forgotten, oh, what do I do? Do I multiply? Do I divide? Do I move the decimal? What do I do on this one, right? So, so this setup just is the same approach for every possible scenario and every possible twist that can come up, which is really nice. So we're going to take those, we're going to rewrite them as fractions, and then the solving is the easy part. So 62 to 100 becomes 62 over 100 equals n over 8529. And remember, we're going to start to do this faster and faster, but we look at our two cross products. This cross product here has the variable in it. This cross product here does not have the variable. That's the one we want, the one that doesn't have a variable. And then we identify the cross product without the variable. We're going to multiply, and then we're going to divide by the other number, which I've circled in blue there. So we multiply the cross product that doesn't have a variable, then we divide by the other number. We go straight to our calculator on that, unless you really love doing long division and multiplication. We get 5287.98. And well, I'm thinking we don't want to put decimals. So the question didn't say to round to the nearest whole number, but you're talking about people who are voting. So having 0.98 of a person doesn't really make sense. So clearly this looks like 5,288 people voted for Jana in the election, which is 62% of the total voters. So there's the idea. We identify the percentage in red, we identify the part and the whole on the right-hand side, turn them into fractions, and do our little shortcut solve. Here's another one. Massa always tips 18% at restaurants. If he left a $3.87 tip, what was the cost of his meal before he added his tip? Massa, by the way, is Japanese name, short for Masahiro. Massa was my roommate for a couple of years after university. He was a real character. If we had time, I could tell you all kinds of stories about Massa, great guy, but we're not going to do that. Today, we're going to solve a percent equation I made up using his name. So 18%, well, identify that first. There's one side of our equation, 18 to 100. That's the easiest part of the whole question, probably. Now, he left a $3.87 tip. What was the cost of his meal? Well, we know he tips 18%, so that 387, that sounds like the percent to me, like the part. And the total cost of his meal sounds like the whole. So $3.87 is 18% of what number is what we're basically asking here. So $3.87 tip, which is the 18, right? 18 is to 100, as 3.87 is to what was the total price of his meal. Turn them into fractions. Oh, I skipped a step there. Turn them into fractions. Identify the cross product that does not have any variables. That's the one you're going to multiply. Then you're going to divide by the other numbers. So here we go. N is equal to, oh, that one didn't get color coded. Normally I would have put the top in red and the bottom in blue. So multiply the cross product, then divide by the other number, and you will get 21.5 for an answer. Now let's interpret that, because this is a word problem. We want the cost of his meal, so you wouldn't say that's going to be $21.5, right? You'd say $21.50. So there we go. Mass's meal before the tip was added was $21.50. Why Massa would choose to tip exactly 18%, I don't know. That is not a true part of my roommate Massa. That part of the question was made up. Oh, bonus question. What did Massa spend in total for his meal? I don't know if they'd ask you this or not, but they might. So he spent $21.50. Then he added on a $3.87 tip, like so. So he spent $25.37 in total. Okay, there's our second quick example. I think we're going to do one more, and then we're going to talk about one other idea before we wrap up. West conducted a survey as part of a project. I also knew somebody named West, by the way. I'm just pulling names out of my past here. West conducted a survey as part of a project for their stats class and found that of the 215 students in the class, 166 had brown eyes. What percentage of students in West's class have brown eyes? I emphasized what percentage there because that's always what we're looking for first. We're looking for the percentage in the question, which in this case is an unknown percentage, so unknown number to 100, right? And in every question, we identify that percentage first, whether it's something we know, 23% or 52% or whatever, or it's something we're looking for, unknown, n to 100. Now we want the part in the whole. Well, I think this one's not too bad. Of the 215 students, that sounds to me like the total number of students, the whole. Some of them, exactly 166, that's the part. So identify those two numbers as the whole, all of the students in the class, and the part, the ones that had brown eyes. So there is your ratio set up. Turn them into fractions. And now we're going to solve by finding the cross product that doesn't have a letter in it, which is that one there in red. We're going to multiply those two and divide by the other number. So n is equal to multiply and divide. On your calculator, you get 77.2093. Let's go back to the question. How many do they want us to round, or is the rounding obvious from the question, like the ones who voted in the voting example? You would never put point something of a person. In the money example, they didn't need to tell us the rounding because obviously we're going to give our answer in dollars and cents. But in this one, we're finding a percentage, and they have specified for us right here that they want us to give it to 2 decimal places. So we can do that. 77.2. So that 0 is what we want to either round down or up based on the digit that's right after it. The digit after it is a 9, so we are going to round that 0 up to a 1. 77.21% of West's stats class have brown eyes. Okay, so there's 3 examples. If you're you may or may not have noticed, we actually, again, picked up one of each of the 3 types of percent equations that can arise. Those 3 examples had one of each of those. Okay, last idea before we wrap this up is something called percent increase or decrease. And that's a special type of percentage word problem. And the reason that this is a really valuable tool is because this helps us determine how significant a change in something actually is. Because just knowing a whole number change, um, like let's see, like how many more arrests did the police make this year compared to last year? How many more people got a certain illness than, or how many fewer maybe because you're vaccinating against it or something? Knowing that 4,000 people fewer got sick, well, what is I mean, that means a lot maybe in a small town, doesn't mean very much in the entire world, right? So percent increase or decrease helps us sort of determine, okay, was this actually a significant thing or just maybe not so much? I think I give an example here. Yeah, so if over the course of a year we do some research and we find that the price of an iPhone went up by $1, well, that's really not a big deal at all, is it? That's basically no increase at all for when you're talking about the cost of an iPhone. But if the price of a chocolate bar goes up by $1, that's a lot, because that's practically doubling, or maybe not anymore, but that's a significant increase to the price of a chocolate bar, but not a significant increase to the price of an iPhone. That's what percent increase and percent decrease will help us to analyze. So we still use the same setup, the part to the whole and the part to the whole. The left side is still going to be the percentage out of 100. The right side, though, we have a special little system. So we use the change in value as the part. So how much it went up or how much it went down, just as a positive number. And we use the original or the starting value as the whole. All right, so we're gonna give that a try. Yeah, so it's gonna look like that. The percent increase is this thing we're finding here, the n. N is to 100 as the change is to the original. So the part is the change in price or people or whatever it is you're measuring, and the whole is the starting amount, the original amount in the word problem. So here we go. According to one source that I actually looked this one up. I didn't make these numbers up. According to one source, the average cost of rent for a one-bedroom apartment in Victoria rose from $1,749 in 2021 to $2,107 the next year in 2022. Calculate the percentage increase in rent during that year, according to this source. All right, so let's give this a try. We want to use our new setup. Part to whole is what we do for all the percentage questions, but for the percent increase questions, we want to find the percentage, so n to 100. So again, we identify that percent first, which in this case is an unknown number. And we know that for the part and the whole, what we're looking for is the change and the original. So how much did rent change during that year? Well, we're going to have to do a little subtraction to figure that out, because it went from 1749 up to 2107. So we subtract those numbers and we find that the change in rent was 358. So that is our part. So the part is the change. And then on the right-hand side, we want the original rent price. So it's either going to be this number here or this number here. It's whichever one came first. So be careful. It's not always the smaller one, because if the price of rent went down, the original would be the bigger one, right? So it is the starting value, which in this case is the 2021 value, which then increased in 2022. So there is our part and our whole, which for percent increase decrease questions is the change over the original, or the change over the starting amount. Once you get that set up, you are off to the races. And by the way, this is why you show me all your work on your tests, because let's say you set this up wrong. Let's say you made probably the most common mistake on a percent increase question. Let's say you stuck that 2107 instead of the 1749 on the right-hand side. Or another common mistake is people forget to calculate the change and they just use these two numbers, 1749 and 2107. If you do that, obviously you're going to lose some marks because you made a mistake, but if I can then look at your work and see that you followed your ratio equation through to what would have been a correct answer, I can give you lots of part marks still. Okay, so turn them into fractions. Identify the cross product that does not have a variable. It's that one there in red. So we're going to multiply those two and then divide by the other number. Here we go. N is equal to the red one's multiplied divided by the blue one, which is 20.4688. That's the percent increase, and they want it to 1 decimal place, they say right there. Okay, so that 4, look at the next digit, rounds up to a 5. So the percent increase in rent during the year was 20.5%. All right, so that gives you an idea. That's a pretty significant increase in 1 year for rent to go up, which is definitely something we have been seeing in Victoria over the last 15 years, but in particular the last 5 years, it's getting really bad. For the rent to go up, 3 or 4% in a year is probably pretty normal. Maybe even more like cost of living increases, more like 2%, like inflation would be around 2% typically, 2 or 3%. But this is huge, right? Over a 20% increase in rent during a year. And we got one more. The book value of a used car gets smaller the older it is. I looked up these numbers too, actually. A 2010 Honda Accord had a book value of $57.42 in 2020 and a book value of $42.68 in 2025. So calculate the percent decrease. Notice the value went down, so it's percent decrease instead of percent increase during that 5-year period. And we're going to round this one, it says, to the nearest whole percent, which is easy. We can do that. So we know all of our percent questions, we're looking for parts and wholes, and we're always trying to identify the percentage first. Calculate the percent. So there it is. The percent in this question is an unknown, n out of 100. And now the part and the whole. Again, for our percent increase decrease questions, we use this special extra little twist where we are looking for the part being the change in value. Let's go over to the side and calculate that. I subtract. And notice I just subtract, in this case, I just subtract bigger minus smaller. I just want a positive number. How much did it change? I'm not going to do a negative if it went down and a positive if it went up. Although, I guess you could. You just get a negative percentage answer and you wouldn't want to write it as a percentage, because when you say what is the percent decrease, the fact that it's going down is already built into your language, right? Okay, so the change is 1474. There we go. That's the part. And the original, the whole is going to be the original value. So the starting value, which in this case is the bigger one because it started at 57.42 and went down. So that is our whole. There we go. We're set up. And now we're going to turn those into fractions. We're going to identify the cross product that doesn't have a variable in it. It's that one there in red. We're going to multiply those and divide by the other number, like so. 25.6705, and then we want to round that to the nearest whole percent, which looks like 26% in this case. All right, so that's that, and maybe worth just a quick reminder as well here that remember this little shortcut we're doing, we could do it a little bit slower by using cross-multiplying, which is also a shortcut in and of itself. We could do it the slow way, which would be Math 053 equation solving chapter, where what we actually did here, this shortcut, what it's actually doing is we are clearing the fractions by multiplying both sides by 100 and multiplying both sides by 57.42, so the denominators go away. And then we're solving the equation that results, which we would solve by dividing by the number that ends up in front of the n. So really we're just doing equation solving there, but because this special equation comes up so often, the shortcut is really handy to know.